Hello, everyone, and welcome to another interesting session of bringing NFTs to life using Covalent. I'm sure you're wondering what this boy is wondering in the image as well. Well, what is the actual agenda? If you have seen my previous video, you would have seen that I'm talking about NFTs, describing them, and in an essence, trying to demystify what NFTs are. Well, this video is the second video in the series where we are going to be creating our own NFTs. So, who am I? Hello, everyone. My name is Jnana Lakshmi, also called as Gyan. I'm a covalent alchemist and I'm passionate about blockchains and the community. You can find me on Twitter at Gyan Lakshmi, and I'm always up for any chat on blockchains, diversity, inclusions, you name it. So, how can we create our own NFT? Well, first things first, before we actually start eating something or making something, we need to take a look at the recipe. Well, before we take a look at the recipe, we need to understand what are the ingredients that are required to prepare something. So, what do we need to actually create an NFT? Well, the first thing that we need is the protocol that we're going to choose. I've broadly titled this as the blockchain network here. But ideally, this would mean what is the chain on which you would like to create your NFT. It could also refer to the standard of NFT that you're looking to create. One of the popular standards of NFT is ERC 721, which is what we would be looking at. And in this session, I'm going to choose the testnet of Avalanche network, also known as FUJI network. Well, the next thing that we need is a programming language in which we will write our smart contracts. I'm not going to delve deep into what are smart contracts, but just to give you a brief overview, smart contract is a piece of code that contains your business logic and is deployed on the blockchain. In this case, what are we going to write the smart contract for? Well, of course, to create an NFT. We also need a wallet or something that can hold our accounts using which we can deploy the smart contract on the Avalanche testnet. We are going to be using MetaMask for that. Last but not the least, actually, this should come rather ahead before choosing our protocol as well as choosing our programming language to write the smart contract. It is the storage. In this case, we are going to use interplanetary file storage, that is IPFS. IPFS is a decentralized storage where we can store our information. Well, in this case, what will we be storing? We'll be storing the information related to NFT. We are going to create a dummy NFT that contains of an image and some associated metadata. And the platform that we have chosen for our decentralized storage, that is IPFS storage, is known as Pinata Cloud. So I think we are now good to get started to write and deploy our smart contract using Remix Editor. Remix is a free online editor that is available for those who are interested to learn Solidity and test your smart contracts written in Solidity. So let's get started. All right. So I'm going to go to the Remix tab right now. All right. So in this video, just in the interest of time, we are not going to be writing our own smart contract. So I've just already written a smart contract and loaded it here for you. The smart contract name is Covalent Demo, and this uses the recent version of Solidity that is greater than 0.8.0 in order to use or rather consume the ERC 721, which is an NFT standard for Ethereum based chains or chains which are EVM compatible can also use ERC 721, which is the NFT standard. So in this smart contract, we are creating an NFT of ERC 721 standard. Now, I'm not going to explain the code much, but the most important item for us is, of course, this function called mint with index. Now, minting an NFT is equivalent to creating an NFT. An NFT can have multiple tokens associated with one NFT address, which can be called as a collection as well. In this case, we are going to create a single NFT with a single token and see how that pans out. All right, so this mint with index function takes a to address. To which address will the NFT be minted? An index, that is going to be the index of your uh, item, whatever you are minting, and a token URI. What is a token URI? A token URI refers to the link of the metadata for that particular NFT. This takes me to our Pinata cloud, where our NFT is actually going to be stored. So I already have an account on Pinata. You can just go to pinata.cloud and sign up, and you get 1 GB of free space to just play around with your NFT. You can also write scripts to directly upload your NFT images and metadata onto Pinata Cloud. So I have already uploaded some metadata as well as some image that would go with our um, that we would be using for this particular video. So you can see that I have an image called colors, right? This refers to the hash of this image, which is sitting in the decentralized storage, and this hash represents this particular image. Now we have colors, and with that, I have a metadata file called colors.json, which contains some details about the NFT. For example, the name, a description, the image link, who was the artist, and what was the creation date for this particular image. Now, when we think about the token URI, we would need to pass this particular metadata URI, because this already contains the image URI inside that, to that particular function while we are minting our NFT. So if you want a detailed tutorial on how Solidity and Remix Editor works, I'll be creating some and putting up on YouTube. But just for the sake of time in this video, we're just going to move with the different components, assuming that all of you are already familiar with these things. So now, as I said, I'll be using MetaMask to deploy the smart contract and to access the accounts. And the testnet account, the network that I'll be using is the Avalanche chain. We'll be using their C chain. So Avalanche provides 3 chains: P chain, X chain, and C chain, where C chain is used for the smart contracts. And Fuji is the name of the testnet chain. So I have already created a test account and I have some AVAX in them. These are dummy AVAX. You can go to Google and type something like Avalanche testnet faucet, and you should be able to see the faucet that will provide you with these dummy uh, AVAX, which you can use, right? So I think you may have to go to the docs and then figure out what is the faucet. And of course, you can also Google Avalanche testnet on MetaMask. So you will get setting up MetaMask for Avalanche, right? So you can set it up and then fill up your account with the faucet free AVAX tokens. So now that we have some AVAX tokens, let us go to our remix, right? And what we would need to do is, in the environment, we'll change it to injected Web3. So it has connected to the network that is all right. So it's taking a bit of time. Okay. So you can see that the test account 0x5D51, you can see the same address over here. And then you can see that the balance is 20.3 AVAX. Here it is reflecting the same. Why do we need to fill up some test AVAX in this? Because to deploy a smart contract, you need to pay some charges, right? You need to pay some fees, and that fees would come from this AVAX. Now here we have the contract, and While deploying, it would ask for the name of the NFT and the symbol. So I'm going to give the name as Covalent Demo and the symbol as CBDM. All right. Now I'm going to deploy this smart contract. So to deploy this smart contract, it would bring a pop-up on MetaMask. Right. And it would ask me to sign the MetaMask transaction. So right now the MetaMask transaction is processing. So you can see that the MetaMask transaction is confirmed on Etherscan and the contract is deployed, right? So actually Remix is a little difficult to see, but if you scroll down on the left side, you will be able to, yeah, the contracts metadata is also published. Thank you. And you can see a bunch of functionality offered by this particular contract. We won't worry about the other functionality. What we want to do is we want to directly mint our NFT. Now, to which address do we want to mint? To the same address that we have on the testnet. So I'm going to copy the two. I'm going to give the index as 1. In the token URI, I'm going to give the URI generated by the metadata. So here you go, transact. All right, yet again, it's going to ask me for a MetaMask confirmation. MetaMask confirmation to come through. All right, now the transaction is confirmed and we have our first ever NFT minted, right? Now, how can we see the details of this NFT, right? That is the catch here. So let's copy this address, which is the contract address. This is going to be your NFT contract address. We can add this as one of the tokens on MetaMask itself. So you can see assets, can add token. So it's automatically come as CVDM. All right. So you can see that one CVDM is what I have, right? Now, what I'm going to do is now, how does Covalent come into picture, right? So here is where I can get the token. So if I want to get the token balances for this particular address, right, I can use Covalent. I'm going to copy this particular address from MetaMask. So this is the address of my account. Now I'll show you that in this address, you can see all the different assets that this particular address holds, also along with the new NFT that we have created. So the chain ID I'm going to give as 43113 for Fuji C-Chain testnet, the address string, and I'm going to give the NFT as true. All right, let's check the response. So you can see a bunch of other NFTs that I had created earlier as well. Yeah. So here is our NFT, right? So you can see that the contract address of that particular NFT is here. The name is Covalent Demo. The symbol is CVDM. You can see type is NFT. You can also, in fact, see the token URL for this, right? Now let us copy this token URL and paste it on one of our browser tabs. Yeah, and now you can see the metadata, right? Interesting. And let us, oh, so not just that, but you can also see the external data. That is the token URL, the metadata is being given to us in the form of external data. So the name, the description, in fact, the image link, which we can just copy from here and paste it in the browser. It's giving us the image. Voila. So we have successfully created an NFT and we have used Covalent to see the NFT related data that we just created. Exciting, right? So there are so many other APIs that Covalent provides with respect to NFTs that we can use to get information related to NFTs, related to our tokens, token metadata, etc. Right? So that was all in this video. Thank you everyone for joining me today and being able to watch this video. I would definitely recommend watching the part 1 as well. So in case you're new to NFTs and you want to understand more about NFTs, in the next upcoming parts, we will look at some other interesting APIs as well as scripting that we can do using the Covalent APIs to retrieve the NFT data. Thanks everyone and have a good day.